Okay, welcome back to another episode. Today we want to have a look at hydraulic cylinders. We want to have a look at failures, the causes, and how we can hopefully give you ways to prevent these things from happening. So let's get in and have a look at some of the cylinders and see what the failures have been. One of the things I want to touch on in this is your system pressures and how important system pressures are. And obviously knowing what those system pressures are is very important to the life and the use or the application you're trying to put your cylinder into. So it's very important if you have a wheel tractor versus an industrial dozer, excavator, scraper. Everything runs a different pressure. Because it will run a different pressure, it's also very important as to what class of cylinder is required for the application to handle the job that you're trying to get it to do. Giving a couple of examples here, you'll notice this particular one here has got a busted piston. That can be caused from a few different things. It could be just a poor casting at the time when it was made. It can also be caused from shock load, system pressure build-up, can also cause this sort of event to happen. One of the notable things around differentials in system pressures is usually what we call the wall thickness of a cylinder or a barrel, and that's usually brought about by the design of the cylinder for the application that's meant for. One of the things I wanted to probably highlight why system pressure is important and some people misunderstand is that a cylinder might be rated at 3000 psi for argument's sake in the agricultural world, sometimes 3.5. But most most industrial equipment is probably running up in the capabilities running particularly around anywhere between 4,000 and 6,000 psi. So there's a huge difference. That huge difference requires a different structure, a different way and means to the way the cylinder is made and manufactured to withstand the different pressures and workloads that you're putting it under. So very, very important to know what your system pressures are when you're buying a cylinder or thinking about making or designing something. That's when you really need to be coming in and talking, and hopefully we'll do our best to give you the right information and supply you with the right equipment that's required to do your application. One of the fallacies or traps that we come across in the hydraulic world, particularly around cylinders, is that we think we've put a cylinder on there that's rated at 3000 psi, and we think that the cylinder sometimes can actually bell or bevel out, I should say. So in other words, it becomes out of round. That can happen mid-stroke on the barrel, and we wonder how that can happen when we're only putting 3000 psi into it, and the cylinder is rated at even higher than that sometimes. And we struggle with the idea as to, well, how can that happen? So I just want to quickly touch on that and help you understand that when a cylinder is left in a particular stroke length, which is usually the working stroke length that you require, what controls that cylinder can sometimes be a hydraulic valve in the form of a traditional spool valve. It can also be counterbalance valves and other pilot lock check valves that also lock cylinders in place. So if you can picture a cylinder that's actually trapped, the oil is trapped on both ends of the barrel at the same time through the valve, and you go over a large rock, or you might drop it through a table drain or drop into a pothole. That pressure that is between the valve that's controlling the cylinder and the barrel is what we call trapped. So it can't go anywhere. So what happens is that we get what we call in the industry a pressure spike. It's the pressure spike then that is generated by the force of the momentum that's put into that cylinder as it's extending that workload. So the system pressure at that point in time is not 3000 psi, which might be a system pressure in the machine operating it. It can be X, it can be anything. Think of a number, and obviously that number is high enough in multiplications to cause that cylinder to bell out and come out of shape. When it comes out of shape, it's not always noticeable, but when it comes in, and we as a company, we pride ourselves in looking for the reasons behind failures, not just that they have failed. We like to know why it's failed. And belling is one of those things that can happen from time to time. Sometimes you can't see it with the eye, other times you can. But what happens is that when it passes past the area of the barrel where it is belled, you get bypass happening on the piston seal, obviously causing that cylinder to not want to keep up or hold its position when you're using it. And sometimes, depending on the damage, it will actually destroy the piston and also destroy the barrel in the process. Okay, thanks everybody for coming back, watching this episode. Please come and see the team at BJ Hydraulics. Everyone here will be more than happy to greet you and hopefully find out the information and ways to go about your issues in the repair site. Thanks again for watching.